Hello and welcome to the second video of this tutorial series. This video is we're going to be developing the chessboard class a little bit more, because before we can even think about a genetic algorithm and a neural network, we need a simulation, a simulated environment. So we need to define our chessboard and define that behavior first. Right now I'm getting organized and I'm creating a couple new packages to because we're gonna have so many classes that we want to make sure we have organized packages. And so let's just create an engine structures package, which is just gonna have just kind of general data structures that hold information, not really process much information, just store it. And that's what we're gonna put in our structs package. Our game objects package is going to store the things that are part of the simulation, which is the chessboard. And since it's a game, I'm calling them game objects, but you could call them entities too. And it's going to store things like our pawn, bishop, rook, knight, queen, king, and just the empty board square, as well as the superclass, which we're actually going to work on that next. For the moment, let's just forget about valid move and the engine structures. We're not going to be working on that quite yet. I was getting ahead of myself in the last tutorial. Let's just create a new class in game objects called board element, and that's going to be our superclass for all of our pawn. It'll be what is inherited by the pawn, rook, and all of the game pieces in a game of chess. Once we've created the class, we can start defining the fields and the different members that will make this a unique, that will kind of unify all the pieces and summarize what each of the pieces will do and behave. We're all going to have a row and column as well as a type. The row and column, you could call it X and Y if you want to. It's just the rank, and it's going to represent the rank and file. You can even use that. Rank and file of the chessboard. The type is going to represent if the current board square is white or black or an empty tile. And every board element is also going to be able to read from the chessboard. This is important because the pawn and all these different pieces need to see around them. So we need to be able to read around our current location and see what other tiles are surrounding the current board element. With that being said, let's have some static final constants that are global that we can use to sort of standardize what a type looks like. So black pieces will have maybe the value 0, white pieces maybe the value 1, and empty tiles maybe the value 2. It doesn't really matter as long as the values are unique. We could even probably use an enum to represent all of our game pieces, but that's up to you. That's more of a design decision. That would work. I think I might have used an enum in the last version that I made, but I think this time we're going to use just a couple constants and make things a little bit simpler. Decide on naming it type empty, type blank, and after you do that, we just need a general constructor for now that will just set all of the instance specific data in the class. This equals that, and that equals that. You can hold Shift Alt S to generate that for you if you want to. Auto generate the code. That's what I usually do. We also want some getters for all that instance specific data too. So for row, column, and type, we need getters. Those getters can also be generated with Shift Alt S, and you can select all of the members that you'd like to create getters for. Notice that we're not creating a getter for a chessboard. It's just not necessary. We really only need that will only be read from by the class. We don't need a third-party class to get the chessboard from some specific member of the pieces. We don't need to get the chessboard that way. Oops. My Russian keyboard seems to be on. I'm going to switch to that. I wonder if it's possible to program with Russian syntax. Anyways, we need to create a setter. We can I don't really want to auto-generate the setters this time because we kind of want to set, whenever we set row, or whenever we change the row, we're most likely going to want to change the column too. So our set is going to change both row and column at the same time, or rank and file, or X and Y, or whatever you decide on for your names. That pretty much sums up our board element class for now. We can go ahead and create a pawn class and have that extend the board element. The pawn class, once created, will be concrete, and it's going to extend from board element. The only logic we're going to put in it today is just the default constructor that it needs, as it's overriding the board element. And we'll work more on the logic for all the pieces in the coming tutorials, because that's what we need to do to get the simulation done and dusted. And then, of course, after that, we'll implement the genetic algorithm and perceptron pretty much simultaneously. They'll need both kind of at the same time. So anyways, once you have that constructor all set up like such, we can head on into the chessboard class and start laying out the initial piece layout. In the chessboard class, we're going to have a 2D array of board elements. These board elements will be an 8x8 configuration, because the chessboard has eight rows and 8 columns. And we can hard code that in, because I have no intentions on having a scalable chessboard sizing thing. This is just going to be standard chess, although you could make a weird chess game with an abnormally sized array and set your pieces in different spots. But yeah, this is just going to be a regular chessboard, so I'm just going to hard code all those values in, and that would be good enough. We want the board elements to be private because only the chessboard should have authority over moving squares and changing square values. We don't want that to be contained outside of the chessboard. And once we do that and set that to be private, we can start putting in our layout for the pawns. Eventually we'll assign a position for each piece, but for now we're just going to place pawns in the matrix. In chess, the pawns are always placed along the 2nd and 7th rank. Rank. So that's exactly what we're going to do, except we start counting from 0 with Java arrays. So we're going to place these pawns at the 1st and 6th position for the row, and that's going to correspond to our 2nd and 7th rank to a chessboard, because that's the behavior we're trying to model with this simulation. So that means we're going to have the squares at the 1st and 8th position be set to a new pawn, and that new pawn is going to take in a row and column. So again, that's 1 and the 8th position. The type is kind of arbitrary. You can pick white or black. I picked black for really no particular reason. And then it takes in this for our chessboard. Once you finish typing and accessing that static constant within the board element type black, and you finish passing in this, copy and paste that, because we need to fill in the white or black, whoever you didn't have last time. So for me, I need to set up the white pawns, and that's going to be the 6th row at the 8th, so 6i, and then that's how those row positions will be defined, very similar to black. So I think that's the end of this tutorial. The next one, we're going to add in bishop, rook, and all those guys, and try and get the whole entire chessboard defined with its initial pieces. And then maybe have like a little output so we can see a little console representation of the chessboard. Thanks again for watching, and don't forget you can get the source code for this tutorial series on the GitHub. The link is in the description. See you in the next video.